Great. Okay. Let me turn on my video, I guess, if you guys want to see me. Yeah, seems to work. Um, well, thanks for joining, everybody. Today we're gonna talk about the data quality workbench, and go through what it is, what you can do with it, how to get it installed, hopefully. Um, Joining me are my colleagues Shirajit and Olav. I will start out and take you through some of the features of this tool that we have developed, based on primarily a lot of work that was, I think, pioneered by Olav. And we have tried to produce something that will hopefully be useful to all of you. So let's get started and dive into it. So what is the DQ Workbench? Well, it's actually a server-side tool, not a JavaScript app, but something that we have developed in Python. There's a couple different reasons for that. Primarily because we want to be able to run this on a server at a regular interval. Unlike a JavaScript app, which needs to run inside of a browser, sometimes we need to schedule some relatively long running process on the server, and Python's a good choice for that. We have also developed a user interface that helps you to get everything set up. So there is a user interface to facilitate developing a configuration file. Once you have that configuration file, it can then be run without the user interface, like strictly on the command line. What this does basically is to store counts of data quality metrics as normal DHIS2 values. I'm sure most of you are probably familiar with the data quality module, where you can see the number of, or see actually the validation rules, which ones have been violated, where, what periods, things like that. Just so that you know what I'm talking about, we can just look quickly in the data quality module. For instance, validation rules. We'll go to validation rule analysis and we'll choose, I don't know, we can just choose something here and choose A and C. So this is great. This does show you exactly which validation rule problems exist, and where. Part of the problem that we've seen, though, in many cases is particularly at higher levels, like the national level. If you're looking to do data quality analysis, you'll often see something like this. It says more than 500 values found. Please narrow the search to see all of them. So what that means is the server is telling you, I actually found more than 500, but I'm only showing you the first 500. This is great for people that are entering data, maybe for district level people that are following up with individual facilities to resolve data quality problems. It's not always really ideal if you're at, say, the state level or the national level, and you want to have a very broad overview of where are the major problems with validation rules. Is it in Bo? Is it in Port Loco? Is it particular data sets that are problematic? Let me shut down this as well. So that's part of the problem with this user interface, basically, is that it works great for people that are looking to resolve their data quality problems and they're going back to the data entry screen. It doesn't really work very great for having an overview of what the data quality situation is, both in terms of geography, but also in terms of time. So is it getting better? Is it getting worse? We don't really have a great overview of that from this interface. So basically the idea with all of this, and there's a couple different metrics that we can calculate with the data quality workbench. One of them, of course, is validation rules. So what the workbench does is that we retrieve all the validation rules, and instead of storing the actual result of the validation rule violation, what we store is a count, a number, basically. So if one facility has 10 validation rule violations and another facility has 0 validation rule violations, that can give you a kind of qualitative feel of the problem. In one facility that has 10, which is maybe not great, and another facility that has 0, that's ideally what you're looking for. So it's really just a sort of arbitrary count, right? Where higher numbers are worse and lower numbers are better. Because these are stored as normal DHIS2 data values, just like any other data value, aggregate data value in DHIS2, we can look at them over time. We can use the data visualizer to track, basically, and see, is data quality always bad, or is it maybe bad at the beginning of the month, and then by the end of the month, people have had time to go back, resolve any data quality problems, and the numbers will hopefully get lower over time, and also hopefully not be persistent. Shirajit will talk a little bit more about this later on in the presentation. So the whole idea here is that we can basically improve data quality by essentially looking at metrics of data quality as a number, right? Previously, we couldn't really do that. We could only look at the individual violations. Well, we didn't really have a way to measure that and store it over time, basically. So that's what the data quality workbench is doing, partially. It does some other stuff as well. So here's sort of the basic workflow. There's a couple of different kinds of things that we can measure at the moment. We can look at outliers. If we go back to the data quality module, you can also see that we can do outlier detection. Let's choose, I don't know, we'll choose morbidity, Sierra Leone, and we can choose an algorithm and some other things here, and we press start. So this is a way basically of seeing all the outliers that we have based on the parameters that we chose. Again, this is a very similar sort of view as the data, as the validation rules. I'm just going to check the comments here to be sure. Yeah, okay. Yes, this is a very similar view that we had with the validation rules, essentially. We get the individual data values. We can mark them for follow-up. What it doesn't tell us necessarily, though, is where are these outliers? Are there particular problems? Are there particular districts, particular facilities that have consistently outliers? That may point to data quality problems. It may point to people not doing follow-up, basically. So we can think about taking this view and then reducing it down to an individual count per facility. So if one facility has, say, 10 outliers, again, that's not as good as a facility that has 0 outliers. That's kind of the basic idea. So we can create these stages basically to do different things. We can look for outliers. We can look for validation rule violations. We can also look at the data, metadata and data integrity checks. That's also potentially a measure of data and particularly metadata quality, but also data as well. If you've got bad metadata, then that may not be great in terms of collecting good data. So those can also be scheduled and collected as a normal DHIS2 data element, a data value. And then we can look at that in the normal visualization tools in DHIS2 using the data visualizer. So this is the sort of first part of this is the app itself that has a user interface that will help you to create these various stages to create a workflow, essentially. So here's some details about the server configuration. Basically, we need to interact with a DHIS2 instance. This could be any DHIS2 instance, really. An API token is used for the configuration or for actually communicating with DHIS2. So you will need to create an API token, not using your username and password. You should obviously be very careful with this because during the process, you will develop a configuration file. That configuration file will have this API token stored in clear text. So you should obviously be very careful about that. You should not develop this configuration on a shared computer. You shouldn't email it. You shouldn't necessarily distribute this over insecure channels. So API tokens are perhaps not as sensitive as usernames and passwords, but they should still be essentially treated as one. There's a couple different things that you can adjust here. Obviously, the URL, the API token. There is logging that's available in the app. This is probably most useful, maybe if you're trying to diagnose what's going wrong. If something isn't working, you can change the logging level to debug, for instance. But for normal users, info is fine. You can also control the number of concurrent requests. The app will make multiple requests simultaneously to the server. This is going to depend a little bit on, how beefy your server is. Probably 5 to 10 is fine. You may need to experiment a bit if you have a kind of underpowered server. Then you may want to consider to lower that number. That means that whatever the workbench is doing is going to take longer since we're not making as many concurrent requests, but at the same time, it may not overload your server. So you may need to experiment a bit with that. Yeah, the last two settings I'll skip over for now. They are documented in the documents. So what you end up with at the end of the day, once you've gone through all of this, is a YAML file, yet another markup language. It's very similar to JSON in many respects. It's a little bit easier to read. But the basic idea here is that the user interface can be used by a data manager, someone that understands DHIS2, that understands data quality. They then develop this YAML file and then can hand that over to the system administrator, right? The system admin, the guy taking care of the server, doesn't really necessarily need to know anything about data quality or DHIS2. They just need to know, here's a configuration file that has been developed by a data manager, someone that has expertise in data quality and DHIS2. And they can set that up as a scheduled task on the server, and then basically replay this analysis every day, so that every day we get a new snapshot of data quality, validation rule violations, integrity violations, outliers, things like that. Any questions so far? Okay. Well, let's move on. So I've talked a little bit about this validation rules. This function basically maps validation rule violation counts for selected groups over a time period. So basically all that we do is to retrieve all of the validation rule violations, we count them up, and you can see and then store those as a normal data value in DHIS2 and work with it just like we would with any other data value in DHIS2. You can see here that there's variation, I think this is maybe the district level in Lao. And it looks like for VN10, they have more validation rule problems than, say, Bokio, right? So there is a single value that's stored per org unit and period at the level where the data is collected, right? So that's how we get it back from the validation rule API. It gives us the validation rule violation for the location where the data was entered. And that's exactly also how we store it. So that allows us to basically have the data disaggregated both in terms of time as well as in terms of geography. Outliers, basically exactly the same thing. We'll talk a little bit more about some of the methods. Olav is going to talk in more detail about this. There are various ways that we can, various ways that are supported on the server to classify what an outlier is, including z-score, modified z-score, and max, which we'll also get into in a minute, and also looking for invalid numeric numbers. So just to be clear what I'm talking about here, that's in the data quality. We have a number of different algorithms that we can choose from here, modified z-score, min-max values. So the workbench basically does exactly the same thing, right? We look for the outliers. We can choose modified z-score. We can do start. We get a list of the outliers here, and then we simply produce a number and store that in DHIS2. Metadata integrity, this is another basically function that is very similar to the validation rules and outliers. In this case, we're going to map a count of the number of data integrity violations at a particular point in time. And these are derived directly from the data integrity checks in DHIS2. Just so that you know what I'm talking about, we can go to the data administration module, and we can go to data integrity, and we can run the checks. And so you can see that we get a number here, right? Categories which are enabled as a data dimension, but which have no associated visualizations, right? We could work on resolving this problem. And then, let's say it takes 2 weeks to figure out how to fix this problem. And in the meantime, the data quality workbench is running. We get a number of 5. We resolve a few of the problems. And after we fix everything, we get a number of 0, basically. So that would allow you to track metadata quality over time, essentially, and store it as a normal value in DHIS2. Right. I think I'll maybe switch to a demo now, and then we'll come back to the min-max stuff. Does that sound okay, Olaf?
Yep, sounds good.
Yeah. So in terms of getting this installed, you can head over to our GitHub page, and it's called Tool DQ Workbench. There is a README file here. There are a number of different ways to get this installed. Docker is one option. That may be appropriate for people that already have Docker or are familiar with it. That works great if you're on Linux. It also, I think, works good on Mac if you're on Mac. So we've included a brief README file here about how to get things up and running. For those of you that are on Windows, you can go to Releases, and there is a Windows setup exe file. It's for those of you that are on Windows, there is documentation that's available. I think that I mentioned this in the documentation. This is one of the quirks. Basically, this is a Python app. We have not signed it. So when you download it in Windows, the smart screen will warn you basically that this file has not been validated by Microsoft. You can then click on keep and then keep anyway. And then once you do that, you can actually install the the exe file on your Windows machine. Hopefully this will work. We've tried to get this together before this this webinar because we know that people have had quite a bit of trouble getting this installed in the past. Hopefully these installers and Docker will make it a little bit easier. If you're still having problems, feel free to report any issues that you might have on the GitHub, and we can see if we can fix it. So once you get it running, hopefully, you can then open up the web page. I think on let's see. Yeah, so if you're using Docker, it's going to be on port 5001, I think. So localhost 5001. I'm running it via a local setup, so mine is running on 8,000. But you will see in the when you start the app that it will run on a particular port. You just need to open that up in your browser and you should see something similar to this, but in this case, I've set up a few things for this demonstration. So I've got a little bit more content here. I think the easiest thing to start with maybe is the configuration screen. We've already gone over this a little bit. Just fill in your base URL. That's your server. In this case, I'm using DHIS2 locally. You have to put in your API token. We can change this. And we just click save. And basically, that's going to save all of that to the configuration file. I think the integrity checks is maybe the easiest place to get started because there's not a whole lot to configure there. But there are a few things that you need to keep in mind. So this is the integrity stage. We just need to give it a name. We also have to define a couple of things to facilitate the storage of the data. One of them is that we have to create the data elements, actually, to map the integrity checks onto a data element. Okay. So there is a button there to help you to do that. These get created inside of DHIS2, and this is some weird bug that I keep getting logged out of the system. We can go to the maintenance app, data elements, and all of these are going to begin with MI in brackets, I think. There. It's weird that these show up as well. But all of the ones that are related to metadata integrity, we have prefixed with this special square brackets MI to stand for metadata integrity, right? So these are created automatically by the app and are just normal data elements basically in DHIS2. In later versions of DHIS2, particularly version 43 that's coming out, you do need to create a data set as well. This may not necessarily be required on earlier versions of DHIS2, but I think it's a good idea to do it anyway, because then that allows you to check the data through the data entry screen. Sometimes that can be useful. So you can just create a normal data set, call it metadata monitoring, or whatever you want to call it. You should keep an open future period, so 1, because what happens is that the app is going to basically store the data for the current period. Normally, we don't store data for, March 2026, but in this case, we're going to store the data for March 2026 if it's weekly. So that would refer to this week. Normally in DHIS2, you wouldn't enter data for the week that we are in right now until it's over, until the end of the period. So you should leave at least one open future period. You can leave everything else as it is. Shirajit may want to talk about this, or Olav later, or just feel free to jump in. You can choose the periodicity here. In this case, I've chosen weekly. What that means is that you're going to end up with a data value for the integrity checks per week. So if you're running the job every day, then you will overwrite values which you populated yesterday. I think, Olav, you mentioned that it made more sense maybe to store them monthly. I think it makes more sense to store it daily. But I don't know. This, you guys might need to tweak this a little bit and see what fits best. I think the advantage of storing it monthly would be that you would probably expect data quality to, particularly for metadata, it may not vary that much, right? So does it really make sense to store it weekly? I'm not sure. It could also be good to store it daily because in this particular case, you might want to see if you introduce a new data set or something happens, a new program, and you see a spike in the validation rule, or sorry, the integrity checks values, then you know that, well, whatever we did yesterday must have caused this problem. But you can experiment with that and see what fits best for you. I then add all of those data elements to the data set itself. So all of these basically are going to map directly back to a data integrity check somehow. And I assigned it to the root org unit, in this case, Sierra Leone. Um, there is no disaggregation by geography, right? The metadata integrity checks apply for the entire instance. Um, the the next step is to configure a data element group. The data element group is there basically as a means to allow you to configure which of the checks you want to monitor. You may not want to monitor all of them. If you want to exclude certain ones that may not be relevant for you, you can always just exclude them, right? And they won't be monitored. You won't get a value for that. So the data set basically is a way to store the data, whereas the data element group is a way to say, okay, I only want to monitor these particular rules. I don't want to monitor the other ones. So now going back to the data quality workbench, there is let me just delete this one and I'll just recreate it. So delete this. And then we'll do new integrity stage and we'll call it metadata integrity monitor. I had created a group and I think it was called metadata monitoring group and metadata monitoring. Active means that it's going to run basically from the command line. You could also, maybe if you want to keep it, but you don't want to have it active, you could choose to inactivate it, but that's what that does. And then we can do create stage. The workbench allows you to do this locally, basically. So this is going to be running from my own computer. And it provides the data manager a way basically to test and be sure, is this working the way that I intended it to work? So when I hit run here, then we're going to trigger the data quality or the data integrity checks, and it tells us that 94 values have been imported. So we can check that maybe, and that's one of the good ways of, we can go back to the data entry app, and I'm logged out again for some reason. We can choose metadata monitoring and Sierra Leone, and we'll choose this week. And you can see that we have the values here, right? Aggregate data elements not in any data element groups, right? So we should see the same thing if we go to the data integrity, go to data administration, data integrity, and we search for that, and you can see that we have 140, right? So that's where that number is coming from. And the basic idea here would be that, okay, this data element is not in any data element group. Let's say that we're going to resolve this metadata problem. So we're going to put it in a group. We can go to the maintenance module. We can go to data element group, choose something. And we'll put this in a group basically. Okay. So now when we go back to the data administration module and run the data integrity checks again, data element groups. Okay, now we only have 139, right? So if we were to run the workbench again, then we would overwrite that value, right? So we're going to run it again, and we're going to store the new value. It should be 139 this time. And the basic idea here is that, if you're doing this every day, you will be able to take a snapshot of what the current situation is, basically. So we go back to the data entry module, and we load up and logged out again. And metadata monitoring. And I still have 140 for some reason. So I don't know. Just needed to refresh. It was cache. So yeah, we got 139 there. So that's the basic idea with the data integrity checks. Any questions? Okay, great. The other functions work very, very similarly. The validation rules, you choose a validation rule, you give it a name, you choose the organization unit level at which you want to make the request. In this case, I've chosen 1. What that does is that it's going to look at the top level organization unit and all the children underneath. That may be stressful to the server, so you can also specify, maybe level 2 or something. That means that you will have more requests, but it may be nicer to the server, basically. So it might be a bit slower, but it might work better on your server depending on the situations. Similarly, you need a duration, how far back do we want to look? How far back do we want to calculate the validation rules over the past 12 months, past 6 months? And also similarly, we have a validation rule group. We do need to define a particular data element. In this case, I've just created a data element and called it ANC validation rule monitor. And then the data set as well needs to be created, particularly in versions 2243 and above. This may not be required on lower versions, but I think it's a good idea to include this anyway. So just create a special data set for this, call it validation rule monitoring or whatever, so that you can keep up with it and put that data element inside of it. Very similarly, what is going on in the background now is that we're downloading all the validation rules. We're going to calculate them for each of the organization units. We can see that we got 4,150 values. So we can go back now to the data visualizer. We can open this up, logged out again. And I think I called it DI ANC validation rule monitor to update. Okay, we can change this around a little bit. Maybe put the periods on the columns, organization units on the rows. We can change this to, say, user subunits. And so a few things, that we can see here. We've got Sierra Leone here. Maybe we can get rid of that. And basically this is going to give you something, whatever happened in September 2025, right? We don't know what happened there, but it looks like there's a lot of problems, right? Otherwise, it looks pretty good. But for this particular time period, there seemed to be a lot of data quality issues. Of course, we can also, drill down to lower levels. We could select, only maybe one particular can do, I guess, user subunits. Yeah, and you can see that, we can continue to go down into and see actually, I guess even individual facilities, right? So can only select those two. Yeah. Okay, well, it looks like there's nothing going on there, period. Sorry. Hide an organization unit. That's a little bit weird. Oh, so it's somewhere inside of one of these, I guess. Yeah, so this would allow you then to figure out exactly where these problems are. We've got 9 inside of Boompa now, so we can open that up. We can select everything inside of there. Let's get rid of these. Yeah, and then this is at the facility level, right? So this then would give you an idea of where you could begin to maybe follow up with the districts and say, okay, in this particular, looking good for basically all other time periods, but in September 2025, there seemed to be a lot of problems. I'm not going to cover the outlier stage. I think we're a little bit pressed for time, but again, this works very, very similarly, right? You give it a name, decide a duration. You need the data set that you want to search for, like morbidity, for instance, right? There's different algorithms you can use. And then again, you need to create a destination data element and a threshold. You can read more about what all of these buttons do in the documentation. I think we are a little bit pressed for time. So I'm going to turn it over to Olav now, who's going to talk about min-max generation.
Yeah, thanks, Jason. So let me just open the slides here. Should I do this instead? Okay, so let me just quickly run through this min-max generation. So this is slightly different from what Jason has been talking about so far. So what we've looked at now for the monitoring of metadata of outliers validation rules has basically been about counting issues and putting the aggregate counts back into DHIS, where you can use them for analysis, etc. This min-max generation is slightly different. So as a background, I'm sure many of you have seen this min-max functionality in DHIS in some form. It's been there for as long as I can remember. And there's a small screenshot at the bottom here showing what it looks like in the new data entry app. But this is functionality that lets you set up for every single combination of organization unit, data element, and category option combination. It lets you set up a minimum and maximum value that is sort of acceptable for that particular combination of org unit, data element, category option combination. And if you enter a number in the data entry app, which is outside that min-max limit, it will give you a warning to say that this is an unexpected number, basically. It still lets you save the value. It's still sent to the server, but there's a warning to the data entry user that something looks strange here. So together with the validation rules, this min-max functionality is the only way really to prevent the data entry mistakes from happening in the first place. The problem with this has been that setting this up in DHIS can be done in two ways. One is by manually in the data entry app editing this for every single data element and org-init. So when I say for every org-init, I mean that these min-max values are actually individual for every single org-init in the system. So when you set up a min-max for one particular hospital, those min-max values are only valid for that hospital. You have to set up different min-max values for a different clinic, for example. So doing it manually doesn't really scale. And the functionality in DHIS for generating this in bulk, it doesn't really work well enough. So you are able to select a data set, select some org-inits, and have the system generate min-max values in bulk, but that's using just basic standard deviation with a fixed number of standard deviations from the mean as the sort of min-max threshold. And that doesn't really work well for a lot of the data in DHIS. So you get a lot of false positives and weird things like minimum threshold being negative, etc. So I think it's not used very much, this functionality. In the data quality workbench, what we've done is to set up functionality for setting these min-max limits in DHIS in a more flexible way. So I'll come back to what that means, but basically you can, within the data quality workbench, configure more specifically how you want these min-max values to be generated, and you can do it quite fast in bulk using some new APIs. Using different statistical methods. And within the data quality workbench, you can also do previews to look at what the particular configuration of min-max thresholds would actually mean in practice. We're looking at historical data, so you can see, okay, if I use these parameters, it would give a lot of false positives. So this doesn't work. Or you can try something else, and you can see then this creates two sort of wide bounds for the limits, and you can play around and try to come up with a configuration that works for particular datasets. So the assumption with this min-max generation is that you might need different thresholds and statistical methods for different datasets within DHIS. So depending on the facility, you might need different thresholds and different statistical methods. For a small clinic or a big district hospital, for different types of data, you might need different methods, different thresholds. So some might be more seasonal. Some data you might expect that most facilities report quite a few cases every month. Other things you expect very few positive numbers ever to be reported, etc. So that's sort of the assumptions with this functionality in the data quality workbench. So to be able to do this, it lets you set up similar to what you've seen now for validation rules and outliers, different stages where you define what data sets you are generating min-max values for. And then within each of those stages, you can have group the data by different metrics. So you can say, okay, any facility that has a median reported value of 3, so tiny facilities, they should use this particular method to set the min max. Maybe just setting a fixed max for 50, for example. And then the large facilities should use this kind of metric. Since there's a lot of possibilities here, we don't really have any guidance on what is an optimal setting. This is quite new and experimental. And that's why we have this preview function built in, so you can get the CSV file that you open in Excel, and you can see what would the results be if I use these settings. So I think the goal here is not to try to set up some perfect min-max limits, but something that is good enough to prevent the big data entry mistakes. So that's sort of the rationale for this. Just quickly, the way this is set up is very similar to what Jason has been showing now. So you can set up some minimum thresholds for how much data you need to try to do this. You can set up some default fallback values when no data is there. You can choose how many periods you want to go back, etc. And when you run it, you get a similar summary. I think this is not something you would typically do as a nightly thing, as you would for the outliers and validation rules, but maybe a few times a year, you might want to update the min-max values, for example. Okay, so just I'm not going into all this since we're running out of time now, but this is just an overview of the different methods that you can apply then when you're generating these min-max values. So what is built into DHIS is just the Z score at the top, middle top there. But using the data quality workbench, you can use the median average derivative. You can do this box-Cox normalization. You can use interquartile ranges. You can set up just very basic thresholds based on just the average of the previous or previous maximum values. You can set up constant min-max values if that makes sense, etc. And each of these then have some pros and cons and some assumptions about what sort of data they're suitable for. But like I said, I think this is something that it's still new and experimental, and I think it makes sense here to try something out, use this preview functionality to see how well it works for a particular data set in a particular instance. And when you're happy with the results, then you can actually import it into the DHIS2 database. Okay, so we're not going to go in and demo this, but feel free to reach out if you are interested in learning more and trying this out. So now I think since we only have 10 minutes left, I'll hand over to Shurajit to say a bit more about why we think these metrics are important.
Thanks a lot. All right, so I think we've talked a lot about kind of how this works and given you some examples. I just wanted to kind of bring it back together a little bit to focus on why we feel these are useful to use. So the whole idea behind this is that this workbench gives you the ability to track improvements to your data quality over time. Of course, the min-max functions that Olav discussed are a little bit different, but it serves the same purpose in that it's kind of a functionality in DHIS2 that has had a number of challenges and gaps throughout the years, and we're hoping to address it. As you mentioned, we only have a handful of tools available to us to help us prevent data quality issues from happening in the first place. So on one side, we're trying to, proactively engage in solutions that would help us with that type of prevention. But then also what we're also trying to do is when you identify these data quality issues, well, what happens after that? Because we've also implemented a number of new tools to identify these problems and show you what's happening in various ways. And I'm going to just review that real quick. But the whole idea here is to kind of then see, well, based on these metrics that are being produced, is any action actually being taken over time to improve these problems, or are they just persisting in your system? You've identified them, you know they exist, but is anyone going back and actually altering these values? So Jason did an example where he updated the metadata integrity problem that he found with a data element not in a group, and then the value got updated. But you can think about this for the other metrics as well. for outliers, for validation rules. Is anyone going back and fixing those outliers? Is anyone going back and modifying those validation rules? Are those numbers changing, or is everything kind of static and you're not seeing any real change? It also allows you to create some indicators. Olav mentioned in the chat some type of indicators that you can create. This will allow you to kind of normalize the distribution of your data quality and compare geographically, compare across time periods, rather than just giving you a count, a number, because that can be useful, of course. Once you start to normalize these values and metrics, you can understand a bit more how these comparisons stack up when compared to one another. So as an example here, and actually just before I do that, yeah, so we have a number of ways of basically identifying various data quality challenges in DHIS2. And I just wanted to tie it back to that as we've been focusing on the Workbench as a tool and what that allows us to do. So, here's an example of a validation rule, and Jason ran this as well to show you, right? We have a number of ways of identifying these validation rules. But similarly for outliers, we also have a number of functions that would allow us. So I could, for example, open this up, right? To identify our outliers, same thing, right? And the whole challenge here with the identification component is, okay, now we know these issues exist, right? And we can also now measure the amount. And that can be quite useful, for example, at higher levels of our organization unit hierarchy, perhaps at the province or national level, for example, where you want to see the scope or the scale of these issues. But now that we've identified them, is anything actually changing? And that's why we feel these metrics really can be helpful. So in this example here, I've taken a output from the Workbench here. This is on validation rule violations, right? And then if you start fixing them, right, you still need these tools to help identify what they are, find out what these issues are. You need some SOPs, etc., to implement that. So the actions actually can take quite a bit of time in practice. But if you have some kind of strategies to handle these challenges, then hopefully you're seeing when you update these results, you can see here at the bottom here, after a number of these validation rules have been fixed, the numbers start to decrease, right? And they can be quite significant. So you can start to track over time whether or not your SOPs are effective, right? Are you actually modifying these data quality issues that you've identified? Are you fixing them, or are they remaining the same? And this can be true for the three metrics that we've included, and hopefully the min-max helps to prevent some of these issues, like the outlier issue, for example, from happening in the first place. It's not something that would be reflected post when you're kind of looking at things retrospectively, but hoping that basically just prevents these outliers from happening in the first place, as an example. So it does give you a kind of additional tool in your kind of overall toolkit to have a look at, what's happening and basically identifying, whether or not your procedures are effective in having people monitor these things. And, you can also look at the frequency. If your SOP, for example, your data sets are monthly and you're supposed to look at this every month, is everything static once again? I think a lot of what we're trying to do promote with all these tools that we are providing, both in the metrics that I showed for the outliers, just regularly looking at validation rules, etc., is that these things are done routinely. And Jason kind of alluded to this, even having the metadata integrity checks daily in his instance, because then you could see from day to day, are you identifying these issues? Has it been 3 months, 4 months, and every day you're just seeing the same numbers? No one's actually going in and fixing any of these problems. So it also helps you kind of to detect the latency of those issues and how quickly those changes are being performed. And if no action is being done for a significant amount of time. And the idea here that we're trying to promote with all of this is that, people look at this routinely. If your data is submitted monthly, look at your data monthly. If it's submitted weekly, look at it weekly and try to identify those problems and have some procedures in place in order to remedy them. So similarly, we can take a number of these metrics and measures and turn them into indicators to allow us to compare across, geography, across time period, etc. So actually, Olav mentioned this indicator in the chat. But here what we've done, I just have an indicator here that shows the number of malaria data sets without any validation rule violations. Because what we're getting now, or what we can take, is the count, the number of violations. We can also get the inverse, and we can take basically data sets that don't have any validation rule violations. We can do the same thing for outliers, for example. To be able to kind of identify, whether or not there are data sets without any outliers present, for example. And we can start to create targets around this. We can start to compare because the actual number, so let's say, for, this one district in orange here, there are 5 validation rule violations. Well, when I look at that and compare it to the others that might have 0, right? These green ones don't have any validation rule violations. 5 doesn't seem like such a high number necessarily. But when we start to kind of normalize this based on the number of reports submitted, based on other parameters, we can start to get some better understanding of the kind of effect this has within our system. So this is why we're kind of trying to promote these metrics and measurements, is that it's kind of part of the broader package that we have on identifying these problems, but then also performing some type of follow-up action on these. So can help you really to monitor your SOPs, monitor the implementation of those SOPs, also to kind of normalize these types of metrics and measures geographically and over various time periods to get a comparison of data quality, because it can be quite subjective otherwise if we're not kind of able to do it this way. So this is kind of the main reason. We spent a lot of time, of course, focusing on the functionality and showing you how it works. And hopefully you have a better understanding of that now. But then, basically, this data quality workbench ties together many of the ideas we've had previously and introduced around in our data quality toolkit, for example, around monitoring a number of different metrics and outputs. And of course, we have in that same toolkit a number of suggested actions, suggested ways to deal with what we've identified. But this helps us measure that further and see if we're actually making those changes over time. All right, so yeah, so the final slide here just has some resources here for you in case Jason went over kind of the documentation where you can install this from. I've just included those links here. And in case you do want to try this on your own, we will be sharing the presentation very shortly after this webinar, so you will have access to all these resources as well. So I might just hand it back over to Jason, if there are any final word before we wrap up the webinar.
Yeah, great. Thanks, Olav and Shurjit. It looks like we've got 2 minutes, not a whole lot of time. We did a lot of talking. I hope it was useful. I guess we can maybe try and take a couple questions in the time that we have left, if you guys have any. Check the chat here. Yeah, so there was one question in the chat. It looks like these DQ issues validate only one data element at a time. Can it take care of DQ issues involving 2 related data elements? Yeah, absolutely. This is maybe a little bit more obvious if you configure one of these yourself. You can actually use a data element group. I'm not exactly sure how Shurjit set his up, but typically you might just want to say looking at malaria data quality, right? You don't care about individual data elements. You might, but you might just kind of want to lump everything into malaria data quality, which would consist of multiple different data elements, and you could put all of those into a data element group. Then that data element, the result, the aggregate result of that data element group would be stored as a single value. So it gets stored in one data element, right? But you might want to create different data elements, maybe one for malaria, one for ANC, one for HIV. So there's a lot of flexibility there about how you might want to organize it, but it's definitely not limited to just one data element, right? You could You could choose to create a data element group with only one data element and monitor that particular data element. But you might want to lump everything into broader categories. That would be up for you to decide. All right, looks like we're out of time. Thanks a lot for joining. We'll share the presentations and look forward to hearing from you on the community of practice if you have any feedback or questions. Thanks a lot.